Hello. By the end of today's lesson, you should be able to classify any real number. Mathematicians classify numbers based on their characteristics. This is similar to the way biologists classify animals. If you think about it, when they get an animal, first they have to classify, well, is it a vertebrate or an invertebrate, meaning does it have a backbone or not? So we're going to draw a box here that is going to contain all the real numbers. So these are all real numbers. Real numbers are numbers that you can use. You can type them into a calculator, you can do calculations with them. They exist. You will only be using real numbers in math classes. Now, when you get a real number, just like life is classified as kind of like plant or animal, right? We've got real numbers classified as rational and irrational. Now, technically, these boxes are the same size. They both contain infinite number of numbers, but we've got to write more over here. With irrational, it is a number with a decimal that just keeps going and going and going. It never ends, it never repeats. You have worked with a number like that, such as the square root of 2. The square root of 2 is irrational. It is not a perfect square. You can estimate it, right? We approximate square roots, but if we were to actually calculate this out, it would just keep going and it would have decimals forever and ever and ever. Another one is pi. You used pi. Yes, we shorten it. We approximate pi as well as 3.14, but it actually keeps going. There's actual competitions as to how many decimal places people can memorize pi out to, and it never ends. Okay, so it is irrational. Whereas rational numbers include any number that can be written as a fraction. So right in the center, I want you to write the number 2. 2 can be written as a fraction, 2 over 1. Next to that, but a little further away, I want you to write negative 2. Negative 2 can also be written as a fraction, as negative 2 over 1, or 2 over negative 1. And then I want you to write 2/3 over there. That is a fraction. It can be written as a fraction. If we were to figure out its decimal equivalent, 0.6 repeating, it repeats, so it is a rational number. Now go ahead and draw a circle. Notice how 2 is still in the center. That includes both 2 and negative 2. These, not that one, these can also be classified as integers. They are the marks on the number line. So you go from 0 and you go up, 1, 2, 3, 4, you go down negative 1, negative 2, negative 3. So all of those are integers. Some integers, like this one, is also positive. And positive integers are also known as whole numbers. Now, whole numbers include all positive integers, and it also includes 0. But sometimes we write positive integers like this. The square root of 16. The square root of 16, well, 16 is a perfect square. The square root of 16 is 4. So 4 is a whole number. It's also an integer. It's also a rational number. And of course, it's a real number. So let's think of some other numbers to put in integers, but aren't in this category. So that would be negative 3. Or negative square root of 16. Remember, the square root of 16, if you don't specify, they're always talking about the positive one, but there's also negative 4, but that would be out here in the integers because it is not positive. Okay? So let's talk about some other rational numbers that are not integers and that are not whole numbers, such as 1/8. 1/8 can be written as a fraction. It can also be written as a decimal, and that decimal terminates. It ends. 5/9. Now that's a repeating decimal, but it can be written as a fraction, and in its decimal equivalent, it repeats. 4.82. It's a terminating decimal. So those are real numbers. So you can think when you get a number, and you can kind of see which category does it go into. This one or this one, and then can you get into here in this circle? Can you get it into this circle? And then you can tell what type of number it is. Or you can use more of a flow chart. So let's still talk about all real numbers. And you can ask yourself, can it be written as a fraction? If the answer is yes, then we know that it is rational. If the answer is no, then you know it is irrational. And that's where it just ends. It just ends at irrational. And of course, it's a real number. But if it's rational, you need to ask yourself another question. Does it have a decimal that ends or repeats? So if it does have something after that decimal point other than 0 that ends or repeats, like 0.5 or 0.3 repeating, if yes, then you know it is just a rational number. And of course, a real number. Oops, let's put that up there. But if there is nothing after the decimal, so no decimal, other than 0, of course, then you know it is an integer. Now, when it's an integer, you need to ask, oh, is it negative? If the answer is yes, it is negative, then you know that it's just an integer, which is a rational number, which is a real number. If it is no, it's not negative, well, then you know that it is a whole number. So it's a whole number, which is an integer, which is a rational number, which is a real number. Down here, you should try out some different numbers. So some different numbers that I would like you to figure out what they are. 18, and write out all of the different classifications of the number 18. Square root of 5, negative 4/9, and let's do the negative square root of 120. If you can figure out what classifications these numbers have, then you understand how to classify numbers, real numbers. Over here, you should probably pull out some of these new vocab words. The first one you should pull out is real number. You should then probably pull out rational number, irrational number, integer, whole number, and then let's just talk about natural numbers. Natural numbers don't include 0, because when you teach a kid to count, you don't teach them 0, you just teach them 1, 2, 3, 4, right? So those are natural numbers. Thank you.